Hi, this video is to talk about the margin of error, which is a very important concept for interval estimate. So here's the formula for the interval estimate. I put this formula here just for you to understand that what we're doing is we're getting the sample mean, adding and subtracting a margin of error, which means a margin for the error of the sample mean that we're computing. Again, this is a point estimator, and we're giving like an interval, adding a potential error for this point estimator. So we have here the formula, the math formula, the equation, which is the sample mean plus and minus a z-score, which is based on an alpha level divided by 2, and I'm going to talk about this in more detail in the next slides, and the standard error of the mean. So the sample mean you learned from chapters 6 and 7, and also the standard error of the mean you learned from chapter 6 and chapter 7. So you know a lot about the sample mean, you know a lot about the standard error of the mean. So you know these elements already. So this is not new for you. What is new is the confidence level. This is new, and this is what I'm going to spend some time with you. The confidence level, and here's the formula in the background. The confidence level is the Z alpha is denoted by the Z alpha level divided by 2. Okay, so this is the probability that the value of a parameter falls within a specified range of values. Okay, it varies. This confidence level varies from 0 to 100, and typical values are above 80%, like 90%, 85%, 95%, and so on. Okay, so where does it come from? Where does this Z alpha level divided by 2 comes from? It comes from the empirical rule and the distribution of Z scores that provide a percentage of the total area of a normal distribution. Remember, I showed you, let me show this one. This is the empirical rule. This is the distribution of all values. Here on axis, we can have different values for different variables, and at the center we have the mean. And if we add and subtract one standard deviation of the mean, we have 68.3% of all values in the distribution. If we add and subtract two standard deviations, so we get the number 2 multiplied by the standard deviation we computed from the mean, or we get from the population, and we add and subtract from the mean, then we have 95.4% of all values in the distribution. So this is what the Z comes from. This number 2, this number 3, those are Z scores, are standardized values. So this 2 tells me how far I am from the mean, above the mean, in this case below the mean. Okay, so this is where this confidence level comes from the empirical rule. So what we're going to do is we're going to define what confidence level we want to have, and then we're going to turn that confidence level into a z-score, and then we're going to multiply by the standard error, add and subtract from the mean. That's what we are doing. So this is what I just said. Oh, I'm sorry. And sometimes you're going to have problems in which the statement says something like, we want to build an interval estimate with 90% confidence level, and then you have to use this confidence level to find the alpha level divided by 2. Or other times the problem says the alpha is 0.1, and then you have to divide by 2 and find the z-score associated with that alpha. Okay, so what are the terms? This is very important, the terminology that you have to understand and know that is associated with this confidence level. The first one is the confidence coefficient. The confidence coefficient is simply the confidence level in the coefficient form, the format. So if the confidence level is, let's say, 10%, the coefficient is 0.1. If the confidence level is 90%, which is typical, then the coefficient is 0.9. Then we use this coefficient to get the alpha. The alpha is called level of significance, and we find the level of significance subtracting 1 from the confidence coefficient you obtain from here. Okay, let me show you more details about this. So these are step-by-step approach that I propose to you to use this concept in the problems. So the first step is to find the level of significance. Okay, so what's the level of significance we want? Is 90%? If it's 90%, what you have to do is, to obtain the alpha, you have to subtract 1 from the confidence coefficient associated with this confidence level. So this confidence level of 90% has a coefficient of 0.9. 1 minus 0.9, your alpha is 0.1. Okay? Sometimes the level of significance, or alpha, is given in the problem, so you don't need to compute. Then you divide the alpha by 2, simply divide by 2. Then you subtract 1 from the resulting number in this step, and then use Excel to find the z-score associated with that. Okay, let me show you in an Excel file. In an Excel, So let's say the confidence level is 80, let's say 95%. That's the confidence level I want. So step 1 is turn this percent into coefficient is 0.9, and find alpha. Find alpha. How I find alpha? I do equal 1 minus this coefficient. Okay, the coefficient is 0.95, not 0.965. Okay, so you found the alpha is 0.05. Step number 2 is let's take a look at slides. Step number 2 is divide. So divide alpha by 2, which is equal to this number divided by 2. Okay. Then step 3, subtract 1, so is equal 1 minus this number here. And step number 4 is use Excel. Find z. So all you want is to find the z associated with this confidence level, so you can go back to the formula here in the background and apply it to the formula and solve the problem. So how you found that? You use the formula norm.s.inv. Because this is inverse, I know the probability, which is 0.975 in this case, and I want to find the z associated with this this probability, which is 1.96. Okay, so this is how you find the z. How you find the z associated with the confidence level you want, and this is all you have to do to be able to plug into the sample mean, and first multiply to the standard error of the mean, and then add and subtract to the sample mean and get the interval estimate. Okay, so I'm gonna ask you to work on find the z value associated with 80% confidence level, and then find the z associated with 70% level confidence, 70% confidence level, just to practice and understand what you have to do. And in the next slide, I'm gonna show you more about building interval estimates and confidence intervals.